So, okay, before we get started, a couple of reminders. Number one, the stuff we've been doing here. Watch the high quality stuff I do here. We've not been doing it for 1, no. Not 2. Oh, let's see if I can keep going. Not 3, not 4. I know this is starting to sound like LeBron James, but it's not. Not 5. Some of you are like, what is he talking about? Okay, this is the 6th day we've been doing this. Now, why do I say that? Because depending on what you've been doing during those 6 days is kind of going to start to show us here on this last day where we are, where we're heading. So my little quotes on here, okay, fall comes before succeed, fail comes before succeed, struggle comes before succeed. Do what it takes to get to succeed. Now, some of you have been doing this. This is good, okay? Just as an FYI, this message brought to you by Mr. H's website, which some of you need to get to know, okay? Where student success is the goal. And the reason I say that is sometimes we think success is just saying, well, I want it. My son does this a lot too. Well, I want it. Good. What are you going to do to get it or to get there? Well, I just want it. No, that's not how this works, okay? So when we're doing these, there's some things, hopefully you've been taking some of the advice you've been getting, which includes use this. And if you don't have one of these yet, I'm not quite sure why you wouldn't, but if you don't, there's blank ones over in front of the folder, and you can borrow one of these from me and get that on there. Again, usable on the quiz tomorrow. To make some of you feel better right off the bat, okay, the quiz tomorrow is going to be 11 questions. Now you're like, well, wait a minute. Your review here is 14. Well, guess what? If you rip the last page up and crumple it up, okay, now it's 11, and that's what we're going to do, okay? So, you're like, sweet, I kind of like this. The only thing that would be better is if I could take the last page and throw it at Harty, but that wouldn't be a good idea. So, see, you hear all the happy rumbling and crumpling of paper in the background. So, when we get to the other part, though, there's some things I have to know, I have to understand to be successful with this. So I look at the top, I'm like, oh dear, he's asking me like wordy questions already. Oh yeah. When referring to rational expression operations, add, subtract, multiply, and divide, when do you need a common denominator? Do I need a common denominator for add, subtract, multiply, and divide? This is where Harty gets frightened. No. Okay, which operations do I need a common denominator for? When do I have to build an LCD? True, but when I'm doing what operations and the denominators are not the same? Okay, multiplying and dividing, we factor, we cancel, we're done. Adding and subtracting, I have to have a common denominator, just like I do when I'm adding and subtracting just plain old numbers. Okay, something you might want to know going into tomorrow. Yeah, when trying to simplify any rational expression that involves quadratic polynomials, okay? Quadratic polynomials. Anything that has x squared in it. I've used that term a lot this year, so I don't feel bad about using it now. Whenever you see something with x squared, what's the first thing you should be doing? Maybe. You're on the right track. Hint. Can I factor it? You're going to hear me say that at least probably 11 times, okay, during this review. So anytime we get into simplifying, And that's true whether it's add, subtract, multiply, divide. Can I factor something? Can I simplify it to make it a little bit easier? So as I start to work my way down, what are the least common denominators for the following? Now notice, it's just asking me for the least common denominator. It doesn't say solve. It doesn't say simplify. So the only thing I'm going to care about in any of these first three is what's going on in the denominator. We are going to completely ignore the numerator because that's what the directions basically are telling us to do. The other thing that I'm definitely going to do as I do these is pull out my help. Now, I wasn't nice. That does happen occasionally. I wasn't nice and I did not put parentheses around where all the pluses and minuses are. You know me well enough to know normally what I do on the preview is what I do on the quiz. AKA, you better remember. So, when I go trying to build my LCD, do I have any numbers hanging out front by themselves in this first one? Do I have any variables that aren't locked in with a plus or minus? So we're all the way down to the parenthesis part. So my common denominator would be x plus 4, x minus 5, because those are the only things I've got there. When I get to the next one, same checklist. Coefficient, this time, yep. Single variable not bound up with plus or minus. You know it. No parentheses this time. Okay. That's not bad. Now the last one. Be careful. Because some of you are starting to look for this pattern and you're like, wait a minute. Everything he's done so far has just been me recopying what I see. I'm just going to recopy it again. Won't work. Why not? I see a quadratic. Whoa, wrong sheet. I see a quadratic. Can I factor it? Can I factor it? Can I factor it? You're like, the way he gets so excited about this? Probably. So let's see if we can diamond this. And you may get one tomorrow where you're just factoring out a common term. That can happen too. So let's see here. Multiplies to a negative, one of each sign. And adds up to 6. So, two numbers multiply to 16. 6 apart. 8 and negative 2. That goes away. And now I look at this and I go, okay, run down the checklist. And again, if today's the first day you're using the checklist, it's one day better than somebody who's not using it at all. So let's do this. Coefficients, nope, everything's in parentheses. Single variables, nope, everything's in parentheses. Okay, parentheses. Question. I see 2x plus 8. Does that mean my LCD is going to be x plus 8 squared? No. The only reason I will ever do squared with a set of parentheses is if the same set of parentheses is in one fraction. Like if these would have both been x plus 8, yes. Yes, I would. But since this is in this fraction and this one's in this one, I will not. I will just write every individual one time. That's what we're looking for. If you're just asked to find an LCD. So we got to look at the directions. Now once we get past that, if possible, simplify the rational expression. In other words, try factoring it first. Okay, see if there's something in common, or if you can do a diamond, whatever, and go from there. But again, I'm going to do this before I even get started on this group, because meanie didn't put parentheses in. So, numerator, okay, there's only one term. I can't do anything with it. Denominator. Those two guys have anything in common? An x. Okay, it doesn't have to be earth-shattering. It can just be an x sometimes. Okay. So if I take an x out, I'm left with 1x in my first term, and I don't need any x's in my second one. So at this point, the only thing that's off limits on canceling is the parentheses, because they're bonded. They're hanging out. They're having a good time. We're not messing with them. I can reduce this with my exponent rules. So here, I'd have 7x, because 2 minus 1 is 1. Bigger exponents in the numerator. I can even put the 1 there if I want to. This x is gone. Okay, I only put my x's where the larger exponent's at. 3x plus 2. Now, one more question before I circle. These are both x's. Can I cancel them? No. Okay? And I have a special term for this. I've not busted this out yet during this, but I'm going to now. Okay? If you are the person that decides tomorrow they are going to cancel this, okay, that is officially a bandage offense. Now, here's what that means. I am going to see those, and I'm going to get so irritated, I'm going to start slamming my head into the wall and cause damage to myself. Okay? Do not be a bandage person. You are not going to be the bandage person. I have things I do. It'll be interesting to see what I look like the day after break if I have people turning me into bandage people. So let's avoid that. Okay. We get to number 2. Everything's in parentheses. Don't cancel nothing yet. Look at your numerator. So first I look and I go, okay, do they have anything in common? Not yet, no. So I take a little deeper of a look. And I go, okay, so it's 2 terms. 2 terms square. Okay, is it a difference of squares? I don't know. 4 and 49. 4 and 49. Okay, yes, it is. So here, I'm going to suggest this again. Whatever I square to get each term, and that should be right on your factoring sheet, I write that down. Because then when I go to write my difference of squares, which you have the formula for right on your help sheet, I just copy the terms that I see up above, 1 plus 1 minus. I'm like, okay, that's not bad. Then I get to my denominator. And I'm like, okay, 2 and 9 and 7. No, nothing really goes into all of those. Okay, so we're going to do a little bit of scratch work. We're going to do a little sliding and dividing. So we'll slide that guy down. And if some of you are strictly guessing checkers at this point, perfect time for you to do that. Get that on there. We get those factored. Now again, I've got to look for clues because I can't mess up signs on this. Positive 14 means both my signs are positive or both my signs are negative. Sign in the middle will tell me which. 2 numbers that multiply to 14 and add to 9. 7 and 2. Don't stop and put those in the denominator. Slide and divide. Now, we've talked before about if it goes in nice, that's nice. If it doesn't go in nice, make sure it's simplified. You punch in 7 divided by 2, you get 3.5. Hit math, enter. You get 7 over 2 back, which means that's going to the front. Okay, this is my factored form. Now that everything's factored, if I see things that are identical, I can zap them. Not close, but identical. And then that, again, is my answer. Don't. Just don't. Okay. 3. Okay, this is the one where we lay back a little bit. Here, I don't see any pluses or minuses. There is no factoring to do. So when I get to this one, this is the one where I get to just multiply across. Now, there's still a couple of things that can nab me if I'm not being careful. The first one being, sometimes people forget with this x, and they'll multiply across, and they'll have x to the fourth. You've got to remember there's a 1 when I don't see an exponent, and then I'm adding exponents as I multiply across. Once I get there, okay, once I get across, now I've got to simplify things. And I'm going to assume, which probably is not a bad assumption in this case, is that we're probably going to use our calculator to reduce the fraction. So 48 over 25 dividing, we're subtracting the exponents. 5 minus 1 is 4. Bigger exponents up top. And the x's, there's only one option. There's the x to the fifth. Nothing else to do with it. I'm done. For some of you, it's just figuring out that part at the end. When am I done? And if we kind of have a little grip on things, it's a little easier to see. Okay, 4. All right. Oh, got to do this again. Get all my parentheses working here. Okay. So I look and I'm like, x to the 6th. Okay, can't do anything with that. Again, I see a squared. I check to see if it's factorable. Maybe I look at my chart and I go, okay, that looks like a difference of squares again. Oh yeah, 36 is a square. Okay, so this is okay. So I square x to get x squared. I square 6 to get 36. And I follow the pattern on my help sheet. And again, those help sheets are still over there too if yours has been misplaced and you need one. So I get that factored. The danger on number 4 is right here. When we have a division problem, the fraction immediately after the division sign flips. Not the first one. Not if there's multiple terms, 2 after that, the immediately after one. So we get x plus 6 and 4x plus 4. And we roll with it from there. Now, if I see stuff that's alike, I can cancel. I can simplify this sum at this step. So I see the x plus 6's. Okay, I can do that. Now let's see what we've actually got left at this point. So if I go across the top, I just see the x to the 6th. And if I go across the bottom, I see 4x to the 4th and x minus 6. Now I have to stop for a second. There's a possibility I may be done. But I still have to look and I go, wait a minute. I still see x's that are hanging out here on their own. I can still deal with this. So, I go, all right, so 6 minus 4, I'm dividing is 2. Bigger exponents on top, so that's where I put my x to the 2nd. My parentheses stay. And it's been one whole problem since I've had to say this. Don't do it. This is bonded. This is in parentheses. This isn't. That's as far as I'm going. And I'm done. And I just keep rolling along with this. Again, not going to be a bad one, sort of like number 3 was. Just means this guy's going to flip over first, so I'd actually rewrite it so I don't do something crazy. But I do notice there's no pluses or minuses. Whew, hallelujah. So, I'm just going to multiply across when I don't see pluses and minuses. So I go ahead and I do that. And I go, okay, let's see here. 84 over 224 is 3 over 8. but I still have the x's left. Okay. 5 minus 4 is 1. Bigger exponents on the bottom. That's where it goes. Okay, we're going to stay very basic. Very simple with this. Now, the last one might freak some of you out. You're like, wait a minute. What's going on here? Okay. We're going to do a couple things to simplify this. First, we're going to take that term in the middle. We're going to make it a fraction, because everything else is. We're going to put it over 1. Second thing we're going to do to simplify this. I see there's a division sign. I'm going to take that fraction right after it, and I'm going to flip it over. So I'm not going to do anything else besides that on this first time through. Okay, I'm not going to do factoring. I'm not going to do nothing fancy. So all we did basically was flip the last fraction over and turn it into multiply. Okay. At this point, let's pause for a second and let's look. Do we have any sets of parentheses that are identical that I can whack? Yes. I see an x plus 3 in the denominator. I see an x plus 3 in the numerator. Okay, that's going to simplify things some. Now I go looking a little more, and I go, okay, is anything factorable? Maybe. 4 and 25, 4 and 25, 4 and 25. They're perfect squares. Woo! So, 2 times 2 is 4. 5 times 5 is 25. My plus and minus. Okay, so we'll get that out of the way. And I take another peek, and I go, ooh, more chances to get out some of my mathematical frustrations. Whack a parentheses. We'll zap those. Now let's see what we've got left. So I look around up in the numerator. Nope, that's gone. Nope, that's gone. I got an x. Okay. Nope, 1. 1 doesn't do much for me. 2x plus 5. Bonded. Single. That doesn't mix. Okay. This x is not going to get zapped out by anything, and I'm done. Okay. So you may have to do several things as you're doing these to make this work, but that's okay. Yes, sir? How come what was that? Okay. So if at any time when we're multiplying or dividing, if I see an identical set of parentheses, those I don't even have to think twice. Just here, it took me a minute because I had to see this was in a disguise in its factored form. So that's why I waited until this step, because I couldn't start whacking yet because I wasn't sure what this looked like. Now, when I get to the last part again, this kind of goes back to our checklist. And I hope I'm answering the question correctly. Here is that this x kind of is working at this level with the single variables that are kind of going. This x is working at the parenthesis level. If I'd have just had like 2x there at the end, I absolutely could have with the x's. But once this is in there, the only way I could have canceled this is if I had another 2x plus 5 somewhere. Good question. Now, as we head to the back, we head to our arch nemesis. Adding and subtracting. Don't forget, we need common denominators. So, parenthesis it up first. We ain't going to screw that part up. Okay. First things first. Bust out the checklist. Unless you are so comfortable now, you don't need it anymore. And start working your way down. Again, just the denominators. Do I have any numbers hanging out on their own? No. Do I have any variables hanging out on their own that don't have plus or minus attached to them? No. So all I'm going to have in my denominator are my sets of parentheses. So the x plus 3 and the x minus 2, they're different, they're unique. They both get included. Okay, whoops, off the screen there. What also gets included? The 4 and the 2 that are already there. So this is the point we get to have the discussion on how we've been building our numerators. And we've had 2 main ways we've been looking at it, so I'm going to do one of each on these fractions. One way is to look at my old denominator in comparison to my new and go, okay, I got this x plus 3 thing, but I don't have this x minus 2. So that's the piece I need up in my numerator. That's one way to tackle it. The other way to tackle it, and I'm going to do this on a sticky note. I'll have some scratch paper as well, so if you need to do this, you can do this tomorrow. My other way, when I'm doing my comparison, is to make a fraction out of it, sort of like what we did on the front. My old denominator, x minus 2, would go on top. My new denominator, x plus 3x minus 2, would go on the bottom of the fraction. And what we did on the front was, well, hey, I see stuff that's similar, I cancel it. Whatever I don't cancel is what gets to appear up in my numerator. Okay? We've got to make this work with one of those two, because there's really not a whole lot of other fancy ways that we're going to be able to get this done. Once I do that, we go into simplify mode. So distribute my 4, distribute my 2, and again, for my big writers, we'll have some scratch paper if we need it. I'm going to combine my like terms. If you're feeling confident, I guess you could do that in the step before. Once we've combined like terms, reminding ourselves they're still bonded at this point. There's still a minus there. Is there anything I can factor out of the numerator that might give me a chance at canceling something? And I look, I'm like, yeah, they're both divisible by 2. So if I divide each of those by 2, now in this case, did that allow me to cancel anything else? No. None of my parentheses are the same. That 2 is hanging out on the outside. There's nothing else hanging out on the outside. So that's all I can do, and I leave it at that. So let's see here. Okay, now I'm happy when I see 8. You're like, why are you happy about any of these? Well, I don't see parentheses I'm going to have to worry about. So when I go to make my LCD, this time I notice I have 2 coefficients. I have 5 and I have 10. So as we've said before, there's tons of ways when it's the coefficients to figure out what number to use. I could write down 5 and 10 and start listing off factors until I find one that's the same. I could take my multiplication chart, find the 5 column and the 10 column, and start working down until I see the same number. Or I even could bust out my calculator for this. Hit my math and go down to LCM and just type in my 2 numbers with a comma in the middle. That'd give it to me. Okay? Lots of options. We just got to find what's comfortable. Single variables? Yep, I got one. And I already made mention that I didn't see any parentheses. So that is my LCD. But again, don't do it. They're like, now why isn't that legal? Because they're all free. Why can't I just cancel the x's right now? I wouldn't have a common denominator anymore. Because now this would just be 10 and this would be 10x. So I can't cancel yet. Not yet. We're going to do this the same way we kind of did before. Okay, 5 to get to 10x. What do we multiply 5 by to get to 10? 2. And I notice I didn't have an x. So whether I did it old school way like that, or I did this, okay, what would I be able to reduce? Well, 5 over 10 is 1/2. And there's the 2x that I multiplied. It depends on the route you want to go. 10x to 10x. Hey, I got the 10, I got the x. I don't need nothing. I mean, I guess I could write 1, but I don't have to. And now we're ready to go into simplify mode. One big fraction. 3x times 2x. 6x squared. 4 times 1 is 4. They are still bonded. There is still a plus there. But do they have something in common I can pull out? 2. Okay. We do not have x with both this time. But I can get a 2. So we'll divide each of those by 2. But then I notice, okay, parentheses off limits. This, though, is completely legal to deal with. 2 does go into 10 5 times. And if you want to put the 1 up here again, you can. We're good. So I've got to keep working my way through those as we're popping through. So then I get to 9. Different issue. I see a quadratic, or again, quadratic is a squared term. I got to try and factor it. Might make my life easier. We'll see. Positive multiply number, same sign. That's the sign. Multiply to 14, add to 9. 7 and 2. Bust out the help sheet. Coefficients, nope, everything's in parentheses. Single variables, no, everything's in parentheses. Unique sets of parentheses, oh, we got those. X minus 7, x minus 2. Reminder again, because I've had several of you ask me about this, and it's been a good question. Well, I see 2 of them, though. Why isn't it squared? Reminder again, and it's right here, too. We never use the squared on parentheses unless the same set of parentheses is in one fraction. If these were both x minus 2's, yes, I would use squared. But they're in 2 separate fractions, so don't do it. So here we got 5x minus 1. We got 2. And we go into the comparison game. Or maybe some of you are going into the super cancel game. We'll see. Old denominator, new one. Got the x minus 7. Got the x minus 2. I don't need nothing. Second fraction. I've got the x minus 2. My new one has x minus 7, x minus 2. Zap the stuff they have in common. Whatever's not in common is going up in my numerator. Okay? I can even do my little check game if I wanted to. So now, I rewrite my numerator, distributing my 2 through. Combine my like terms. I guess somebody out there needs to wake up. Wake up. And always take your last look at your numerator. Nothing goes into 7 and 15. One term has x, one doesn't. That's as far as I'm going. So we got to be meticulous. We got to be very detailed in how we're rolling through these. Okay, a couple to go. Thank goodness we got to rip that last sheet off. Okay. Now, this is supposed to be a layup question. Oh, I hope it is. What do you notice right away? It's a little different about this one. They're already the same. Don't go crazy here. Okay? If they're already the same, we leave stuff alone. all I got to do is 6x minus 36. Okay. Now, do you think I'm going to let you completely off easy? Quite that easy? Probably not. So what do I still have to do? Is there something in my numerator, since I just put it together, that they have in common? Yeah. I can take a 6 out. And miraculously, when I take the 6 out and get what I have left over in the parentheses, check it out. Same set of parentheses. Okay? Got to get that last piece in. I want to make it easier on that, but you still got to do a little bit of thinking. One last one with one last twist. Oop, make sure you get those parentheses in. Factor your denominator. Positive and positive. Okay, that's nice. 4 and 3. Okay, get rid of the old ones so we're not thinking about it. I get to bust out my checklist one last time on this here review. So let's move that up. All right. Coefficients. Nope, everything's in parentheses. Single variables. Nope, everything's in parentheses. Sets of parentheses. Okay, we just got done talking about with the x plus 3, even though I see it twice, they're in different fractions, so I only use it once. And I haven't even made mention as we've been going through, a lot of these are going to have similar problems that we actually did on the sheet. So if you're confused on something, actually look at the problems and see if there's something similar that might trigger something. Okay. Old to new. Got the x plus 3. Didn't check off the x plus 4. Or if you're a canceler, cancel away. Second one, I notice. Oh, x plus 3. Got it. X plus 4. Got it. I don't need anything. The only thing that gets people on a problem... Oh, I'm sorry. That's similar to this. Because they're not in the same fraction. If both of the x plus 3s, like let's say we're in this fraction, then yes, I would do the squared. But if there's one in each, I'm only going to use one. So I'm going to do my distributing. Be careful. This minus, okay, this negative goes to both the x squared and the 6. That's why we always want the parentheses here to remind us of things like that. So it will change the signs on both. Still bonded. Okay, I look for like terms I can put together now. No other x squareds, no other x's. And I'm going to take my one last look. Don't have all of them terms, don't have x. I can't do that. Not all my terms are divisible by anything greater than 1. That's all I've got. Now again, two things. If all you have done through all these lessons is copy what we do together, this will not go well. Maybe homework check stuff is the answer. Maybe making a trip back to Mr. H's website to watch this or some of the other video stuff or the additional video stuff that we didn't do in class is a good idea. But if success is the goal, remember the stuff that comes before it. Okay? The struggle comes before. The fall down and have to get back up comes before. Hopefully not the crying, even though crying does come before succeed, so we could use crying too. But hopefully we don't have tears. But come ready for that tomorrow, and you'll do a good job.